What's the answer?
30.
75. Oh, yeah, 30.
Dude,
You forgot to multiply it by 2. Because if you divide everything by 2, you'd come up with 8. And you'd come up with 17, which would tell you 15 is your other one. But you need to multiply it by 2 to get back to your x. So your x would be 30. Real quick, would this be solvable if I did a squared plus b squared equals c squared? Yes.
We should do that.
But wasn't 30 a lot faster, just kind of knowing it? Knowing those basic ones can speed things up, but they aren't 100% necessary. I will not on the test say you have to use Pythagorean triples, and if you do something, because how am I going to check?
I don't like the triples as much.
How am I going to check? It's good for people that want to go rapidly through problems. That's what they're for. All right, today we're going to rehash hash browns. We're going to rehash our geometric means.
What is this? I don't know it.
It was cross multiplication.
Oh. Really?
Yeah.
Oh.
That's it. And then we're going to use it in triangles, and then on the back side, we're going to make it way easier. All right?
You would make it easy to do it.
Because it's not fun that way. Okay, geometric mean, when the means of a proportion are the same. That the number is called the geometric mean of the extremes, the two numbers that are not the same. In other words, our means and extremes. Our means go with means. Our extremes go with extremes. This is super quick because we already did mean extreme, but we just said that was cross products. So if I ever ask you to find the geometric mean between 8 and 10, which I am not going to, but if I had phrased it that way, you're trying to find that number that goes between them. So we'd go 8 over x equals x over 10. And then you do cross multiplication to give you x squared equals 80. You would take the square root of both sides to give you x equals the square root of 80. But that is simplifiable because 16 goes into 80 5 times. So we could rewrite that as 16 times the square root of 5, which is just equal to 4 square root of 5. I am not going to do the next one because it is just cross. We know how to cross multiply, right?
No.
Or no? Okay, then for Robin's sake, we have to go through it again. Robin, you can do it on your own. I'll check it later, okay? All right. In a right triangle, an altitude drawn from the vertex to the right angle of the hypotenuse forms two additional right angles. Instead, think of an altitude of a right triangle. These three right triangles are all similar to each other. It is very helpful when solving these to rearrange the triangles so that they're all facing the same direction. We did this with similar triangles. So rather than trying to picture all these sides separately, what I would do is I would draw them all the exact same direction. So it says write the similarity statement for all three right triangles. All that's saying is if I would ask for this on the test, all I'm asking you to do is just write AC B is similar to I should put triangle in front. Let's not shortcut this. I just want to get to the good part, which was ADC. We can also say triangle ADC is similar to triangle CDB. And finally, I can say triangle CDB is similar to triangle ACB. Yes, Evan?
What if you wrote them all the same thing?
Awesome.
We can do that?
Sure.
Instead of doing that?
Yeah. He's just saying, what if I just put another similar statement here, and it would cover all three of it?
Oh, okay.
Yeah. He was just saying, what if I put all three of them in the statement? Yeah, you're good. You're good. Because they're all similar to each other. Yeah. Evan was just asking, could I just put another similarity statement here and put this last one attached to it? And I'm like, yep. All three of them into one are similar.
Wait, would you accept us doing that on the test?
I would accept you doing that on the test, yes.
Okay.
So, we can use this fact to actually solve triangles. But this is like the least effective way. We've done this before, and that is pulling out all the triangles that are similar and then all their particular sizes. So let's pull out all the similar triangles. So the first one's pretty easy. That is our EG. Bless you. Jeez, must be allergic to triangles in here. So I'm going to pull out the big one, EGF. Yeah.
Doesn't matter if you draw it and it's not really looks like the picture.
Yeah, I don't care.
Okay.
Just make sure you get your letters correct. Make sure you get your letters correct. All right, the next one I want to draw. Let's do the one with... I'm going to do the one that has GHF.
Wait,
No?
sorry, I'm really sad about the placement of this.
Did I pick GEF?
No, I did it differently.
Oh, we'll see. And the reason why F's have to match up is because they're their shared angle. F is the shared angle here, so I need to kind of pin it in the same place here. Our last one is GHE. Well, that means our E's must match, so my E must be the top of my EHG. So let's go ahead and draw that one. Once again, I'm going to kind of draw the exact same triangle shape, just so I keep this thing. I know E has to go on top, and that must mean it goes EHG. Now I'm going to go back and fill in those values now that I have them all down. So G to H. G to H is my X. So G to H is X here. H to F. H to F is some value. Let's leave that off for just a second. But I have G to F is 4. G to F is 4. Now we look for E to H. Once again, I don't really have a value yet for that. We'll hold on to that for a second. We have E to G is 3. And finally, H to G is X. Again, I just need to find the value of X. Do I really want to spend the time solving for this and this? Is that going to help me at all? No, not really. We just need to find ratios between the two triangles and use that to help solve for our X. So let's just look at these first two triangles here. I'm going to look for two things that they share. Well, they share a 5 and a 4. So for these two triangles, I'm going to say 5 over 4. So I went 5 over 4, and using my similarity statement, I can now say equals 3 over X. Well, doing cross multiplication, I'm just going to come up with 5x equals 12, so x is just going to equal 12 over 5. Well, this is the same x that's there, so if I would do this 5 over 3 and 4 over x, you're going to come up with the exact same answer. You come up with 12 over 5, and that's all they're asking you to do. That is the end of that problem.
Wait, so you don't have to,
I don't have to use the last one at all?
wait, you know how you lined the E's up?
Mm-hmm.
Wait, I did it kind of a different way.
All of your ones that have a shared angle must be lined up. So this complete E, see how the complete E is here? That E has to be the E here if you're lining everything up. Just like this F here is shared with this F here.
Okay.
So that has to match up.
But I felt like if you were doing triangle GEH, if you had it the way that EGF is, then it would be G on the top.
It can't have G on the top. Because G is actually split. I'm using a different portion of the G.
Oh.
For this one, I'm using this portion here. For the one way to the right, I'm using this portion here.
Okay.
Your key is to look for which ones are our full angles. So if you look here, this E here matches up with this E here, and also matches up with this E here. This F, let's put 2 on it, has to match up with this F, which has to match up with this F. Then by similarity statements, G must also equal that F, and this G must also equal that E, but that's what you do when you're drawing it. But here's the good news. After this lesson, ooh, I'm missing a huge chunk of this. Can I take a picture? Thank you. After this lesson, we won't have to redraw these specific triangles.
Cool.
Yeah. We just have to learn how to draw a heartbeat and bunny ears.
Just a little squiggly line.
Kind of.
That's what you were saying yesterday.
What was that?
Won't you do that anymore?
Only if it's a altitude of a right
Oh.
triangle. So this is only going to work if it's an altitude of a right triangle. So this is our altitude. Is that okay? Yeah. Altitude of a right triangle. Oh, that's a rigged. There we go. So you are specifically looking for 2 right angle symbols. That's what you're looking for. Then you can use either one of these methods to figure out what numbers are missing. So this is a shortcut to finding geometric means. This is everything we just did without having to actually draw those pictures. So the first thing is the heartbeat method. And I'll kind of do it in red. So our first step is to go from A to D. So we're going to go from A to D. So on my drawing, I'm going to take my pencil and I'm going to go from A to D. I'll try to make it thicker, however you want. All right, something like that. Our next step is to go from D to C. So we're going to go up. Let me erase this just a little bit. I want to make it a little better. So we're going to go up CD. Then we're going to come back down C to D. And finally, we're going to go from D to B. And that's the heartbeat method.
Oh, I get why it's heartbeat.
Because it looks like a heart goes boop boop. But why is this important? Why is this drawing important versus just being able to draw a heartbeat? Yeah.
Does it show you the 2 triangles that you want to use?
It doesn't even show what triangles I want to use. It actually shows me what sides I want to do and write down. So after drawing, what you are going to do is whatever length AD is, you're just going to write that length down here. And then you're going to go over length DC. That's going to equal length CD. Remember, DC is the exact same thing as CD, right? If D to C is 6, C to D, so these 2 numbers are the same. And then that's going to be over DB. You now have your means extremes. Yeah?
Cross out the DC and CD then, since they equal each other.
Well, you can't cross out, you can do cross multiplication.
Oh, okay.
You can do cross multiplication. They're allowed to be the same, they don't get crossed out. Because they wouldn't get crossed out, because if this was 6 down here,
Yeah.
to get rid of it, you have to multiply by 6,
Oh, okay.
and then you have 6 times 6. So they don't quite cancel each other out, but you can jump straight to cross multiplication.
Okay.
And it'll make more sense once we're actually doing the problems using this. Yeah?
When do we know when I guess does it matter when we go up, like the C? If we need to take the line.
We are always... What?
When you go from A to D,
Yep.
does it matter when you like go like?
You have to go up next.
I know, but does it matter?
Because you did it kind of skewed for
Yeah.
Oh, I did it skewed for effect.
Oh.
It's not actually like
It's not actually, okay.
I didn't pattern them.
It's the same line.
Yeah, so a more correct image of this might be if I was... But that's not fun. This is more fun, because then you can picture that heartbeat happening. When to use this? When to use this, and there's a couple instances where you have to use this, but usually it's when the term you're looking for is on the altitude. So like your x. So maybe I'll put use if term is on the altitude. And not just an x. In fact, if there's any number on the altitude, you're probably going to want to use this method, because we're going to find out another method too. We're going to do another method. This one's called the bunny ears method. This one stretches the meaning of a drawing. This you can see is a heartbeat. The bunny ear one, it looks like bunny ears. I think it does. Some people disagree. Step 1. We are going to go from A to B. And how about I draw it as we're doing it? So we're going to go from A to B to D, and we're going to draw kind of down like this. A to B. I'll make that a little less. Boom. Then we're going to go to B to C. Now we're going to go from C to B. And finally, we're going to go from B to D. So it kind of is bunny ears. We definitely have one big bunny ear, and we kind of have part of the other bunny ear.
Look more like bunny ears. What happened to the other bunnies?
You can't choose. You can't choose what you're drawing. So either you think of it as the bunny ears, or you think of something else. But that's the bunny ear
Like a clam.
method.
Oh, yeah.
All right, it's a clam method then. All right, and after we do the drawing, we are going to come up with AB over BC equals CB, which is the same thing as BC, over BD. We're going to use this one whenever we know like these key values and we don't know the altitude. Yes, Sabrina.
Wait, so if it's BD, then why did you like draw an arrow all the way back to A?
I didn't. From B to D.
Oh, wait.
This is my starting off one.
Oh.
And then I went up here, and then I went down here, and then I came back that little bit of distance. Be careful, and you don't really have room. It's going to make yours look like chaos, but you can also go kind of the opposite direction if you needed to. You could go from B to A, up this length, down here, and over here. So I guess I should go that way next year, huh?
Remember that. That one's more like bunny.
But most of the time, it's usually that short side that you know, for whatever reason. But just know you can go the opposite direction. Just like this one, you could go B to D, up, down, and back here. These are just general drawings of what you can do. Let's see why these are important.
But when do you use that one?
You're going to use that one pretty much anytime you're not going to use the heartbeat. So it's where the numbers are. So if you see a bunch of numbers along here and up this route, you're going to use the bunny ears.
Okay.
If you see it on the altitude, you're going to use the heartbeat method. So the first one I see a number is on the altitude, so we're going to use the heartbeat method. I usually go left to right. You can go right to left. It doesn't matter. But I'm going to go from left to right. I'm going to say, okay, we're going to write down 12 first. And it's going to be 12 over, I'm going up. 12 over 18 is going to equal, I'm going to come back down. It is still 18 over y.
That's so much easier.
Wait, what? All right, so we are going to have 12y is going to equal 18 times 18, which is 324. And we're just going to have y equals 27. For my money, this is the easiest way to use means extremes with altitudes of right triangles. There are other people that just do the triangles, where they make you draw all three. What was that?
For your money.
For my money, if I had to buy one of these methods, if I had to either buy this method or I had to buy this method, I'd much rather purchase this method. Our next one, do we have a number on the altitude? No, so that pretty much tells us we have to try the other one. And what's telling me what direction to go? Let's all look up here real quick. If I would choose to go this direction, would I get many values? No, so let's go the other direction. We're going to go from here to here, which would give me z. Then we run up that 27. So that'd give me 27. And we run back down 27 to give me 27 again. And it's going to be all over that 16. Are we all okay with my drawing and where I got those numbers from? Yes?
Just kind of like confused because like the triangle is basically like upside down. So could I change it if I was drawing it? Like, could I change it to like right side up?
If you want to redraw it. But you don't necessarily have to, because we know that this is the base that this is running along. But if you want to redraw it just to make it easier to see, you can absolutely do that.
Oh, okay.
Option.
Wait, you said that like, but there's no like altitude, there's no like second altitude, or is it like, does the altitude have to be like next to each other? Does there have to be one like?
There has to be an altitude.
Oh, there doesn't have to be like a right angle at the top of the triangle.
Right.
Oh wow.
Well, this one is a right angle. It should be. I should have a right angle here. But yeah, there should be a right angle here. It's assumed right now, just for the. But you should look for a right angle and an altitude. Has to have a right angle and an altitude. I'm just telling you to assume. Maybe we should write it in. I didn't realize there was one missing there. I must have forgot to put that one in. So I'm going to put it in now. There is a right angle. Put that right angle there because it does need to be there. Thank you for pointing that out. All right, so that's going to give me 16z is going to equal 27 times 27, which is 729. And z is going to equal, well, not anything super nice. We're just going to put 45.6. All right, our next one. We do have a term on the altitude. Yeah.
I got 45.7.
It should have come out, maybe I have it wrong. I have 45.56.
As long as we're close, though, it's alright. It's not exactly.
When you're rounding, it should be pretty exact, depending on where you round to. Am I wrong? Because I don't have a calculator right now. Okay, when you type it in, you should get 45.5625, which if I round it to the 10th place, has to be 45.6. Yeah.
I realized, I thought when I looked at the 5, I just thought it was a 6.
Oh, okay.
So,
But we're good?
yeah.
Okay, cool. All right, my next one. We have a value on the altitude. We do have a right triangle, and we do have an altitude, so it means I can use a heartbeat or bunny ears. This one means I'm going to use the heartbeat because it is on the altitude, so I'll go 5 over y equals y over 8. Which is going to give me y squared equals 40, which will give me y equals square root of 40. Well, 40 is nice because I know 4 goes into it, so it's actually, you should be able to simplify this on your own to 2 square root of 10. For number 7, if you go this direction, you aren't even going to hit your variable, and you're going to not have enough numbers. So instead of going that direction, I'm going to go this direction. to give me my 8. I'm going to run up the x. So it'll be over x equals, I'm going to come back down x. And I'm going to have over, well, that's 8, but what number am I actually running through here? 6. Because it's 8 minus 2 would give me that 6. So we are going to have x squared. Did I do everything right? Yeah, x squared equals 16. So x equals 4 in that guy. In the next one, we do have to... Oh, I'm sorry.
16. It doesn't equal 48?
Oh, what am I doing? Hang on. Yeah. I was looking at a different one. It's going to equal 48.
I like the heartbeat one better. Sorry, what is this?
So you do 112. You get 28.
Because if the full length is 8,
Oh.
the short length is 6. Yeah.
Because you can,
Shh. There's way too many people talking while I'm talking. Way too many people. That's why there's lots of confusion flying around. I got the 6 from this little length, because if the full length is 8, this little length is 6. So we have x squared equals 48. We are going to take the square root of both sides. What does square root of 48 reduce to?
4 squared 12.
Square root of 4 square root of 12?
Yeah, like can we do time 2 and 3?
Could that go further? Yeah.
Can we do 2 and 3? Or square root of 2 and square root of 3?
Square root of 2 and square root of 3.
Wait, no, hold on. Square root of 2 and square root of 6.
Square root of 2 and square root of 6?
Yeah, because...
I'm looking for perfect squares that go into it, though.
Oh, never mind.
Yes, Sabrina.
4 times radical 4 times radical 3, and that would be x equals 4 radical 3.
Say that again? Because we can just go a little further than Robbins.
Radical 4 times radical 3, and x equals 4 radical 3.
X equals 4 radical 3. Oh, are you saying 16 times 3? Oh, Because 4 times 3 equals 12, not 48.
I said 4 radical 4 times radical 4.
Oh, okay. There we go. Yep.
So then, oh yeah, because the 4s.
Yep, because the 4s. So we actually have 4
Square root 3.
square root of 3, which would be x equals 4 radical 3. In other words, 16 goes into 48 3 times. All right, my next one, I do have to use... are we okay with this slide? I'm going to move to the next one.
Well, 8.
What was that?
8.
No, I'll move to the next slide so I can show 8. All right, 8, we have to use the heartbeat method first to get our x. So I'm going to have 16 over, guys. I'm okay with you guys working, but
sorry, shut up.
that was a nice way of putting what I wanted to put. All right, which is 12 over x, which we are going to now have 16.
Yeah, that's right.
Yeah, that's right. My notes are completely wrong. My notes are completely rubbish right now. All right, yeah. We have 16x equals 12 times 12, which is 144. And what's 144 divided by 16?
She said. Yeah.
So x equals 9. Well, now that we have x equals 9, we can now use the rabbit ear method to get to my y. So we're going to go all the way across, which is actually 16 plus 9, which is going to give me 25, over y is going to equal, we come back down y, over 9. Yep. And then you go ahead and solve that, and you should come up with y equals 15 when you actually solve it all. Yes?
Instead of having to do the second part of it, can we just look at that one triangle and say 9, 12, y has to be 15?
If you did like 9 squared plus 12 squared.
Yeah.
Yeah, you could do that too.
Okay.
Yep. Yeah, because you have 9 times 25 equals 225. 225 square root is going to be 15. I'm going to hold off on doing the next one because I think you can do the next. I do want to answer questions from the homework so that we have time to do everything. Robin.
20 and 20.
20 and...
One of them so I can get like the general idea.
Okay.
I don't know, that's 9.
All right, let me take the pictures. Erase mine really quick. All right, so how we do those, and I'm just going to kind of set them up, and I'll let you finish them. Whoopsies. Whoopsies. I just want to erase all the work I have. Sorry for the clean pictures. All right. So 420. 420, we are going to create a right triangle. And the hypotenuse of it is 1. And I can actually find this measure because this needs to be all 180. So this is going to be a 30, 60, 90-degree triangle where this is S,
No, I completely, yep.
this is 2S, and
I
this
was
is
thinking-
S.
I was thinking that it was going to be 40, not 30. I don't know why.
Oh, okay. No, it's 30.
Yeah.
And let me, I'm not going to
It's a
finish
lot.
it. You're going to finish it?
Yeah.
Okay.
As soon as
I'm
you
going to
have
do the next one with you because the next one's a little weird. So since we're looking for x, y values, if you draw this triangle here, do not draw it. Maybe you did, erase it. This triangle will not get you your answer. That triangle will not actually get you your correct answer. Instead, you want to go ahead and use this right triangle. That triangle is going to be a lot more useful. So we're going to use this triangle, and we're going to say, well, this is 90. This is 180. So this must be 270. So this angle here must be my 30, 60, 90 triangle, where this is 1. And then we can get our values this way. But be careful on these because we can use negative numbers. This is the one time where we're going to use triangles that have negative numbers. So if you're doing this one, you just have to know your x value has to be negative and your y value has to be positive to get to this point. Whatever values you get here, your y has to be negative and your x has to be positive. Okay? Is that going to help you?
Yeah.
This isn't going to be on the test or anything. So if you're kind of confused on these, it's okay. This is more or less prepping you for future math because you will have to do these a lot in future, particularly if you're in pre-calculus. If you ever used to see that unit circle that was up there, that's how they got all those values. Yes?
How do you get like the what? How do you get like the coordinates of G?
Okay, so let's get the coordinates of F. So if I'm getting the coordinates of F, 2S equals 1. So S equals 1/2. And if you look at S, S is going up, so that has to be your Y value. So this would be my 1/2.
So then the
S square root of 3 would be 1/2 square root of 3. In other words, square root of 3 over 2, but it has to be negative since our x value is negative. So that would go in for your x value. And it has to be negative because it's going left.
okay, I was confused on what where
No
and
X.
how and what.
Sorry, why is it over that 2 again?
Why is it over that 2? Because it's s square root of 3. S square root of 3 equals 1/2 times square root of 3, which equals square root of 3 over 2.
Think of square root of 3 over 1, so you do 2 times 1, which is 2 on the bottom.
And since that direction is negative, it has to be a negative square root of 3 over 2. That's why the answer key has negative square root of 3 over 2 instead of just a positive. All right, other questions that are on these, because I don't want to spend a whole bunch of time on things that...
Right?
One of them would be negative. The y value would be
Yeah.
negative, but the x would be positive,
Yeah.
right?
Okay.
Yeah. All right, Stephen. 18. All right, 18, we have to find C, we have to find B, we have to find D. Well, I'm going to look for something that has a value. Well, we have 130 over there. We have B over there. So we have some right angles. Let's start with that. We have some nifty right angles. We have a 30 down here. We have a 30 down here, which makes this 60. I also see this isosceles, so we actually have a 45 degree triangle. Awesome. How do I get to that 130 or that 120? Yeah.
Well, isn't it like 50? A equals 50? Because isn't it isn't I don't know exactly what it.
Well, we don't have to get to any of those degrees.
No, but
It's a Pythagorean triple.
Yeah.
The one that I was having trouble with was D.
Oh, it was D? What did we get to? What am I at?
I got C was 100 and then B was 50 back to 2.
So you have C equals 100?
Yes.
That's in fact all you need. This is a 30-60 triangle. If it's a 30-60-90 triangle, this is S, this is 2S, and this is
Oh, it would be 100 back to 3.
S squared root of 3.
Okay.
Not 100, it'd be 50 radical 3, right?
Yeah.
Yep. So it's a 30-60-90 degree triangle. So Evan, you'd have to use the Pythagorean triples, or you could
Yeah.
use the a squared plus b squared equals c squared.
I used the triples and I got the for A, and yeah, so I got it.
Okay, good. Yeah. All right, other questions?
Yeah. That's what I
No, we're good otherwise? Yeah, sorry.
14.
Oh, yeah, 14. I see 7. I see 17. I must have these backwards. All right, 14.
It's a lot easier when you realize what it is.
Oh, yeah.
That's what I spent like some good time in class figuring it out, and then I got home first. I looked at it first.
On this
and I
one?
noticed- yeah.
Yeah.
It was way easier than I.
Well, you want to help me do it?
Sure.
Okay.
Why not? Yeah. You can divide them by 4 and get your like values.
Yeah, so I get my R value, right?
And then you can get your R value by re-multiplying by 4 when you get that small.
So what's my R going to equal?
It's going to equal 10.
It's going to equal...
Or it's going to equal 40.
No,
but
hang on. What is it going to equal?
40.
40,
But
yeah.
It's going to like you're going to get 10 first.
Yeah, because what's the Pythagorean triple that works for this one?
6, 8, and 10.
6, 8, and 10.
Because you divide 24 by 4 to get 6.
Do you see that? It'd be a 6, 8, 10. So this would be a 100. No, not 140, right?
Like I got
And this is a 30, 60, 90 degree triangle.
2s. 40 is 2s.
40 is my 2s.
Oh, I see what I got confused because the variable was S2.
Oh, I see. So just scratch that off and just say this is s squared. Yeah, or use a different variable. Are you good then?
I think
Because this would be s square root of 3. So my s is 20, so this would be 20 square root of 3. Yep. Thanks, Robin. Other questions?
I pre-tried everything.
Okay. All right, I'm going to check this homework on